Good morning. This is the video that will finish our conversation about binomial random variables. We talked the other day about what a binomial random variable was and then how to find probabilities. And remember, instead of having to do a tree diagram and do it kind of the long way, we have these formulas on the computer or these functions on the computer, the binomial PDF, binomial CDF. Again, very handy formulas. My warning is when you see a problem, if you're given outcomes and probabilities, don't just assume it's randomly a binomial distribution. Make sure it is that before you start using binomial PDF or binomial CDF. So today, as you can see from this title here, now we're talking about the mean and standard deviation of a binomial random variable. You'll recall back in the beginning of this chapter, if I had any random variable where I had the outcomes listed and the probability of each, we could take those x's and p of x's and use the calculator, put them into L1 and L2, and we used the one variable stats L1 comma L2, and it found us the mean and standard deviation. So we could do that here. There's actually a shortcut, which we'll get to. So here's an example. It says I make 80% of my field goal attempts. Attempts are independent. I attempt 4 field goals and let x be the number of made field goals. So that does meet all the criteria for a binomial random variable. Fixed number of trials, 4, that's n. Probability of success is p, and it's the same for each one. Trials are independent. And then the random variable is the number of successes. So I went ahead and already found this table. So if the question would have asked, what's the probability I make exactly 2 field goals? I would have done this binomial PDF. I would have done this to answer the question, what's the probability I make exactly 2? So I went ahead and just found all of the individual PDFs, and those decimals in this rectangle, not surprisingly, do add up to 1, as they should. So that's the probability distribution for that binomial random variable. But now the question is, what's my expected value? How many field goals do I expect to make when I try 4 field goals? And then what's the standard deviation? How typically far from the mean is a typical number of makes in 4? So the mean, it should maybe make sense before I uncover here what the calculator told me. If I'm kicking 4 field goals and I make 80% of my field goals, I think it would make sense that whatever 80% of 4 is would be the mean. That at least intuitively should make sense. But if we don't know that, if we don't recognize that, we can always put the data. It says if I input x into L1 and p of x into L2, I can find, and there's the mean and the standard deviation. The mean is 3.2, standard deviation is 0.8. Now, one thing, like often around here, you have to be able to do clearly is interpret the mean or standard deviation. So what I've done on the next screen is I interpreted both of those numbers. You have to make sure you word it so that whoever's reading what you write understands that you know how to interpret the mean and interpret the standard deviation. So here's my interpretation of the mean and of the standard deviation in this case. So to interpret the mean, it says if I attempted 4 field goals many times, I would expect to make an average of 3.2 field goals. So that's if I repeated that process with that fixed number of trials, 4 trials, if I did that again and again and again, the average number of field goals I would make per set of 4 would be 3.2. And then the standard deviation, again, the interpretation hasn't changed. I know you know that in general, a standard deviation says how far a typical value is from the mean. Be careful how you word it, because the typical value here is a number of made field goals out of 4. So let's hope I worded this correctly. It says if I attempted 4 field goals many times, a typical number of made field goals would differ from the mean of 3.2 by 0.8. And again, I can't really spell, so we'll spell the word would correctly. So that's, again, the overall interpretation of mean and standard deviation should not be new. Just make sure you word it clearly. So nothing wrong with that. What I'm saying, the conclusion here is going to be that I don't need to go through all of this math and then use L1 and L2. As long as you give me that original problem, I make 80% independent, I attempt 4, you can go right from there to the mean and the standard deviation, which is kind of nice. So here are the formulas. And these formulas are given to you on the AP test. You don't have to memorize them. You have to recognize them and know how to use them. And more importantly, know when to use them, which is when it's a binomial random variable. It doesn't work for other random variables. So it says good news. There are formulas for the mean and standard deviation of a binomial distribution. And now the mean is just n times p. Let's think about that. We already had that conversation 2 minutes ago. N is the number of trials, that's 4 in this case. P is the probability of success each time, which is 0.8. And we already said that it would make sense that if I'm doing something 4 times and I succeed 80% of the time, whatever 80% of 4 is would be my expected value. So sure enough, that formula matches that. And that NP is in fact 4 times 0.8, which is 3.2. And then this formula for the standard deviation is not nearly as intuitive. We remember we did the math over here, and we found that the standard deviation happened to be 0.8. Excuse me. At least in this, let's see if that in fact holds. Up here so I can. No, I can't. Okay. So this is the square root of n times p times q. Remember, n is 4, p is 0.8, probability of success. Q is the probability of failure, which is 1 minus p, which is 1 minus 0.8, which is 0.2. So that becomes the square root of 4 times 0.8 times 0.2, which turns out to be the square root of 0.64, which is in fact 0.8. So it's the same answers, thankfully. But if the question just says to find the mean of a binomial random variable, it's just n times p, and the standard deviation is the square root of npq. So those formulas are worth being aware of, and then you still have to be able to interpret your answers for either the mean or standard deviation. So that is actually it for binomial random variables. We have one other type of random variable, which will be Monday's video, which will be the end of chapter 6. Your homework here is just 81 through 86, which really just ask some questions about means and standard deviations of random variables. And I'll post this here on Friday morning and make it due on Monday night. So have a great Friday and a great weekend. Again, continue to reach out whenever you have questions. See you.